Okay, we're starting today, and so we're going to pick up where we left off with solving equations. Our first couple problems should be a nice review, and then we'll get into some slightly more challenging problems. If you haven't started your 7.5 solving equations yet, you're behind. I told you you should be caught up on that by Monday, which was 2 days ago. The whole thing about trying to do mathematics that's easy, I hope you guys understand that, like, that's done. There's no more, like, easy math, right? Every day you're going to have new things. And here's my question to you to try to show you some of the crazy stuff that we're going to try to figure out. Do you know what the square root of 25 is? Do you know what the square root of negative 25 is? 5i. 5i, good. You're really smart. What's the square root of I? No, negative 1 times negative 1 is 1. Square root of negative 1 is I, and I times I is negative 1. 0, 0 times 0 is 0. Somebody give me two things you multiply together to get I. I times I is negative 1. 1 times 1 is 1. It has to be, you got to multiply itself. That's what square root means. Got to be something by itself. You have no idea, do you? Okay? No. I'm going to teach you how to, I'm going to teach you crazy stuff. I'm going to teach you how to find the cubed root of, say, 1 minus I roots of 3. Like, this will be an easy problem by the time we're done with this unit. And that, you don't even have any idea where to start, right? Exactly. We're going to answer that challenging question, it's going to be pretty cool. This unit is not an easy unit. It gets a little bit easier after this, okay? But this is one where you want to be full court press, ready to go. Math needs to be a priority, okay? That's my warning to you. Got it? All right, so let's start. Let's solve this equation. What do you do to both sides? Look at how smart you guys are. 4 sine of 2/3 theta is equal to negative 2. What do you want to do now? Divide by 4. Sine of 2/3 theta is equal to negative 1/2. And this is where we pick up from last time. What's different about this one is instead of just having theta, we have 2/3 theta. So as you look at the operation, we're trying to solve theta. Before we solve for theta, we got to move the 2/3 and sine. Sine has to move before the 2/3 does. Everybody see that? I can't multiply by 3/2 right now. I got to wait. So how do I get rid of sine? Easy. We do sine inverse. We set up our quadrants. This is how we get rid of sine. Where is sine? Negative. 3 and 4. And when I inverse 1/2 on my calculator, what do you get for sine? 30 degrees. So therefore, I have two angles I come up with. What are those two angles? 210, thank you, and 330. So instead of saying theta is equal to that, I say 2/3 theta is equal to that. Are you okay with that? Now I solve by multiplying both sides by 3/2. So therefore, theta will be equal to, if you multiply both sides by 3/2, 210 times 3 is 630, and then divided by 2 is 315. And then if I multiply by 3/2, 330 times 3 is 990. Divided by 2 is 495. Those are my two solutions. No, we'll address that right now. Boring. Not here. Hey, sorry there. Are there? Are there? Boring. All right. So Easton understands that we're trying to find solutions between 0 and 360. When we say that, my interpretation for you guys will be this. When you set up these, find your initial solutions between 0 and 360. If your final ones come outside of that, don't worry. Okay? So when you set this up, look for 0 to 360. See what I'm saying? Okay. All right. The next one. I have cosines on both sides. What do you want to do? Excellent. Before I take out a cosine, what do you want to do? Move it over. 2 cosine squared of 3 theta minus the cosine of 3 theta is equal to 0. Now what? Factor out a cosine. So cosine of 3 theta times what's left? 2 cosine of 3 theta minus 1. It's all right? Because cosine times 2 cosine is 2 cosine squared. You okay with that? All right, I have 2 equations to now solve. I have cosine of 3 theta is equal to 0. We'll start with that one. Cosine equal to 0. You tell me, is cosine the x value or the y value? The x value. Where is the x value equal to 0? 90 and 270. So therefore you have 3 theta is equal to 90 and 270. In order to solve, what will I do? Divide by 3 or multiply by 1/3, and I get 30 degrees and 90 degrees. I have another equation to solve. It is 2 cosine of 3 theta minus 1 is equal to 0. What are we going to do? Add the 1, divide by the 2, and I get cosine of 3 theta is 1/2. How do I determine where cosine is equal to 1/2? Inverse cosine, which quadrants is cosine positive in? 1 and 4. So I go 1 and I go 4. $60. So therefore, 3 theta is equal to, what are my 2 results? 60 and 300. So in order to solve, I have to divide both sides by 3, and what do you get? 20 degrees and 100 degrees. Good work. Let's get into slightly more complicated ones. We have the negative root of 3 times cosine is equal to sine. What is the relationship between sine and cosine? They're not inverses, but thank you for suggesting. Tell me something, anything that relates the two together. Sine squared plus cosine squared is 1. I've got that, but neither one's being squared. One's x and one's y. Sine divided by cosine is tangent. And if you notice, I can use that right here. If I divide both sides by cosine of x, I change it from having 2 different trig expressions to having negative root of 3 is equal to the tangent of x. So tangent of x is negative root of 3. I decide where tangent is negative. Where is tangent negative? Second and fourth. Thank you very much. How do you know that? All students take calculus. And you think of it because they are opposite signs. Good. Yep. However you want to think of it. So I inverse the root of 3. Everybody knows where tangent is equal to the root of 3. 60. What? Sure. Yeah. So what are my 2 solutions? 120 and 300. The next one is similar. I have 2 different trig functions. I have cosecant and I have sine. What's the relationship between cosecant and sine? They are reciprocals of one another. Yep. And so because they are reciprocals, watch what happens. If you were to take sine and divide it by cosecant, what do you get? You get sine squared. Watch how Patty does that. He says sine of x over 1 over sine of x. And if you divide by multiplying by the reciprocal, can everybody see you're going to get sine squared? So therefore, in this situation, I'm going to divide both sides by the cosecant of x, whoop, sorry about that, the cosecant of x over 2, and divide this side by cosecant of x over 2. So on the left side, cosecant of x over 2 divided by cosecant of x over 2 just gives me what? 1. And on the right side, I have 2, and you already told me I get sine squared out of this deal, right? You don't do anything with the angle. It's just, it's, you know, it's like sine of x divided by sine of x. It's not like the x's cancel or something like that. We get that. So now what do you want to do? Good. So I've got just a sine function, so I'm going to divide by 2, so I got 1/2 is equal to sine squared of x over 2. Now what should we do to both sides? Square root. And we get plus or minus the square root of 1/2 is equal to sine of x over 2. Some people don't like that we have the square root of 1/2. That's not my final answer, is it? So I could just leave it and deal with it later. So I would like to get rid of sine. So I'm going to inverse both sides. I have positive and negative. Where's sine positive? 1 and 2. It's negative in the third and fourth. Very good. So I go to my handy dandy calculator. I turn it on, and I press the sine inverse of the square root of 1 divided by 2. And I get 45. Okay, so what are my 4 angles? Good. And that's equal to x over 2. So if I'm going to solve, what will I do to both sides? Multiply by 2. So you can see you get x is 90 degrees, 270 degrees, 450 degrees, and 630 degrees.
Can you repeat how you got like 1 is equal to 2 sine? You do 2 times. You
Divide by cosecant. Yep. So hopefully you can understand that when we first covered solving trig equations last week, they were a little bit easier. Now we're seeing some of the more challenging ones, right? Okay. So let's move along. We have 3 more problems left. This one is quite easy. It's just tough to see where to get started. The key is in seeing what makes this problem different than all the other problems we've done. Can you see what makes this problem different than all the other problems we've done? Very good. You have a double angle and a single angle. Okay, so notice how the angles do not match up. That is the number 1 problem we have to deal with. You can't have a double angle and a single angle. They're not compatible. So did we learn anything in a previous unit about what a double angle is equal to? Patty is on fire. Do you remember that from the last year? Because third hour gave me a very strong no. Awesome. I've got a few from you guys. Sine of 2x is 2 sine cosine. Okay? Yep. So the most important formula you can know from trigonometry is sine squared plus cosine squared is 1. One of the other ones that are most important is sine of a double angle is that. Okay? And so let's use that. So I'm going to replace this with 2 sine of x cosine of x. Minus cosine of x is equal to 0. Now, as Morgan said, just factor out the cosine. We have already determined via a previous problem where the cosine of x is equal to 0. When is cosine equal to 0? 90 degrees and 270 degrees. Good. What is the other equation we need to solve? 2 sine of x minus 1 is equal to 0. Or in other words, where is sine of x equal to 1/2? Where is sine positive? 1 and 2. Very good. And if you inverse 1/2 for sine, you do not get 60, you get, very good, 30. So if you get 30, what are your angle measurements going to be? Yep. What do you think, Gav? I made an observation. Janessa talks a lot in class, but only when she's insulting me. I want more Janessa talk during the mathematics part as well. You're a brilliant mathematician, and you know it. Now she's shaking her head. She doesn't want the responsibility. You can make jokes about sine and cosine if you want. Why do you always got to pick on the bald guy? Oh boy. Okay. Number 6. Now we get to something a little bit more challenging. Any thoughts? I like the idea of tangent. Don't write this down because it doesn't work, but watch. If we divide by cosine and divide by cosine and divide by cosine, because that's what I would have done too when I was your age, I get 1 plus secant is equal to tangent. So I do get the tangent, I get the 1, but then I get the secant. And notice I'm kind of at the same spot I started, right?
What if you square it?
Patty S. in Fuego. So we're going to square both sides. So Patrick sees that we have this beautiful equation called sine squared plus cosine squared is 1. And if we square both sides, we'll come up with a sine squared and a cosine squared, won't we? And we'll be able to then use that. However, we said it a little bit too carelessly. The fact is that when we square things, that's a problem. Like, you might say, well, it's no big to square both sides, Mr. Gens. Think about this, folks. If I write down x plus 3 is equal to 4, what's the solution? 1. And does everybody agree that there is just one solution to that problem? But if you square both sides, you get x squared plus 6x plus 9 is equal to 16. How many solutions are there to that? There are 2, right? There's 2 solutions. Notice how it's x squared. So we've added a solution that doesn't exist in the original problem. So every time you square both sides, you've got to check your answers at the end. That's the risk you run, okay? So Patty, you okay with checking the answers at the end? Okay, we really don't have any other options. So here we go. What do you get if you square cosine plus 1? Cosine squared of x plus 2 cosine of x plus 1. Good. What do you get on the right side? Okay, so Luke is trying to be impressive and jump ahead of us. We get sine squared. Now, Luke is going to use this idea that sine squared plus cosine squared is 1, and he's going to substitute. He saw how we substituted here, and he sees that we're working with substitutions. So he can either substitute something in for cosine squared, or he can substitute something in for sine squared. And what Luke is saying is sine squared is equal to what? 1 minus cosine squared. I hope you remember that from your last unit. That would be essential. So there I go. Cosine squared of x plus 2 cosine of x is equal to 1 minus cosine squared of x. Now I have cosines galore, and I have all single angles. I'm a happy mathematician. What would you like to do now? Well, I forgot about the 1 there, sorry. Yeah, set it equal to 0, so let's add a cosine squared to both sides. So we'll get 2 cosine squared plus 2 cosine of x. And then what else should we do? Subtract 1 from both sides and get 0. That's our new equation now that we gather our terms. What should we do now? Take out a cosine, so or even a 2 cosine of x. And you'll be left with cosine of x, what? Plus 1. How many equations do we have? 2. Where is 2 cosine of x equal to 0? We've already decided that x is 90 and 270 for that one. And then our second equation is really where is cosine of x equal to -1. So cosine is the x value or the y value. When is the x value -1? 180. Now we stated that if we square both sides, we run the risk of adding a solution. So what do we have to do? Let's check our results and see what we get. We plug in 90. What is the cosine of 90? What's the x value at 90? 0 plus 1 equals, what's the sine of 90? 1. Is that statement true? So 90 works. I plug in 270. What's the cosine of 270? 0. And what's the sine of 270? -1. Is that true? So therefore 270 is the added solution. It works for the squared, not for the original. And finally, 180. What is the cosine of 180? -1 plus 1, is that equal to 0? It sure is. So 180 is a solution as well. 90 and 180. You hanging in there?
No.
Thank you for your honesty. I appreciate it. We have our last problem. You guys are ahead of the other class. Get rid of a few people and all of a sudden the lesson goes faster. Who is the loud one? Is it Hannah?
Yeah.
Hannah Wilner?
Yeah. I think it's Marissa and Sydney.
Is it Laura?
And sometimes Laura.
And sometimes Laura?
But I'm still here. And we're glad.
Sydney?
Yeah.
Avery? Marissa?
She's been here. She's been gone for a long time.
Yeah, she's been gone for a long time. Yep. Hi, Marissa. We miss you. Well, we miss all of you guys. But, all right, let's go to the last one. Sometimes you get one where you just say, I have no idea what I'm doing. Those are my favorite ones. They're the ones that finally give you a challenge. Because all the other ones were pretty easy, weren't they? And Patty's saying this is child's play. Like, let's get something more difficult. So what if I told you you've done this exact problem before? In fact, you've done it probably 3 times. What did you say? He'd believe me. Jack is a trustworthy man. I know that. So let's see if you remember. I'm going to try to take this expression and rewrite it. Probably one of the best skills that you can learn as a mathematician is to represent problems in multiple ways. And right now, I don't see anything I can factor out. Squaring both sides is not going to help me. Nothing cancels. So I'm going to write it as cosine over 1 plus sine over 1 times sine over cosine equals 2. What do you notice? Notice something, please.
Oh, it's like, I get it.
You do get a sine squared here, don't you? So we get a sine squared over cosine, don't you? That's nice. And on this side, I have cosine over 1. If I wanted to add those together, what do I have to have? Common denominators. So what would you multiply by to create common denominators? Cosine over cosine. Now, Morgan, what do you see? What do you see? Say it. Yeah, so now Morgan looks at it. She sees, oh, wow. On the top, you have sine squared plus cosine squared is 1. And so you get 1 over cosine is equal to 2. That's our new equation. What is 1 over cosine? So now we have an equation of secant of x is equal to 2. Wow. So that thing simplified to that. And actually, we've done that exact same piece before. We just didn't have it equal to 2. Well, I don't have a secant button on my calculator, but I do have a cosine of x is equal to 1/2. Somebody in which quadrants is cosine positive? First and fourth, thank you very much. And if we inverse 1/2, you get none other than 60 for cosine. What? So I get x is 300 degrees and 60 degrees. Usually we write the smaller one first, but in honor of Ella, we'll do whatever she says. Folks, you are not supposed to all just walk through this assignment and know how to do every problem. Don't be surprised if you have to ask a question or two. I will try to make sure that the previous assignment that you had, that you will be able to see that answer key by tomorrow, and I'll start posting from there. Just a little bit behind on life right now. I'm going to try to get caught back up. So, you sure can.